Hi everybody, so the chemical reaction you just watched in that Mythbusters clip is featuring a type of reaction called a combustion reaction. And a combustion reaction is any reaction where oxygen, O2 gas, the ideal gas, is reacted. And there's a certain type of combustion reaction that's really pertinent to us because we're doing it all the time, and you saw that in the Mythbusters clip, and that's the combustion of a hydrocarbon. And a hydrocarbon is any chemical compound, it's covalent compound that has carbon, hydrogen, and sometimes oxygen. And when you do a combustion reaction, okay, meaning you react oxygen, you burn it, and you burn something that has carbons, hydrogens, and oxygens, you always get the same two things. You get carbon dioxide and you get water. You might notice this reaction down here below from biology. This is the reaction of cellular respiration and glycolysis to produce 36 ATPs. The combustion of glucose. Again, combustion means adding oxygen to make CO2 and H2O. The Mythbusters clip you were just watching was the combustion of methane gas, CH4, and that's not here. And it might have been one of them you did up. Yeah, you actually did one combustion reaction up here. And the combustion of methane gas, CH4, again, burning with oxygen, makes the same two things, CO2 and H2O. So we're going to focus on combustion reactions right now, and when we're balancing combustion reactions, we always follow the same process. So the first thing you do is you ask yourself, Ramsey, is this a combustion reaction? And if it is a combustion reaction, then what we do is we look at it, and we know it is if we see O2 goes to CO2 plus H2O. That tells us it's a combustion reaction. And if it is, we do the same process each time. We balance in this order. Carbons, hydrogens, then oxygen. So what I like to do is write these over here and check them off as I go. But the only rule, when you get to the O's, you want to slow down. You want to slow down because there are O's here and here. There are two O's here and one O there. If I put a 2 here, that would be 4 O's here. If I put a 2 here, that would be 2 O's there. Okay, so when you get to the O's, you want to slow down. So let's do this first one. Okay, here we go. Okay, I'm going to do it in red. All right, how many carbons are here? 3. And by the way, we're balancing each side of the arrow. How many carbons are here? 3. How many carbons are here? 1. It's really easy to think of this as 2, but remember that 2 only counts for the O. So 3 here, 3 here. Okay, carbons are good, so I'm going to cross off the carbons. Now I'm going to go to the hydrogens. How many hydrogens here? 8. How many hydrogens here? 2. Okay, 2 times what is 8? 4. So now I have 8 here and 8 here. So I'm going to cross these off. Okay. Now when I get to the O's, I'm going to slow down. So I'm going to count all the O's on this side. And I'm going to put a number in front of that O to balance it. And that's always the routine. Count the O's here and put a number in front of that O. So how many O's are here? Well, on first glance, you would think 2, but there's actually 3 times 2. There's 6. And how many O's are here? Well, on first glance, you would think there's 1, but there's actually 4 times 1. There's 4. So if I add these up, I get 10. So if I put a 5 here, I then have balanced the O's. So C3, C3. H8, H8. Slow down. 6 O's here plus 4 O's here is 10 O's here. Put a 5 there. Okay? So I'm going to go ahead and do another example of one for you, and that is this one right here. Okay, so it's a combustion reaction, so CHO. Okay, start with carbons. How many carbons here? 2. How many carbons here? 1. So I put a 2 here. Carbons are good. How many hydrogens here? 6. How many hydrogens here? 2. Well, how many of those do I need to make 6? 3. Boom. Okay, when I get to the O's, I'm going to slow down. So how many O's are here? On first glance, you think there are 2, but it's really 2 times 2, so it's 4. On first glance, you would think there are 1, but 3 times 1 is 3. So I'm adding those up, and I have 7 O's on this side of the arrow. So I need to get 7 O's over here. Okay. Now what makes this one a little bit tricky is there's already an oxygen here. Okay. Try your best to never put a number in front of this. Only put a number in front of this to balance the O's. Sorry about that noise, everybody. Okay. So I need 7 total O's. So if I make this 6 by putting a 3 there, 3 times 2 is 6 plus 1 is 7. Okay. So if you see that lone O over there, just subtract 1 out to make 6, and then that's where we get that right there. Okay, and let's do one other example. Let's do one where we don't have a whole number. So again, is this a combustion reaction? Yes, because I'm adding oxygen and I'm making CO2 and H2O. So it's actually the combustion of a hydrocarbon. Okay, this is the reaction that's happening in our bodies right now as I speak. Awesome. So put a CHO. All right, here we go. How many carbons here? 4. How many carbons here? 1. So I put a 4 here. How many hydrogens here? 10. How many here? 2. Some people put an 8 there because 8 plus 2, but it's really a 5 because it's multiplication. How many H2Os do we need to get 10 O's? And then I'm going to do the O's, so I slow down. On first glance, we think that's 2, but it's really 8. On first glance, we think it's 1, but it's really 5. So 13. All right. Now we don't have an oxygen here, so we don't need to subtract 1 out there. So I'm definitely not going to put anything there. Okay, so what times 2 is 13? All right. And it turns out that's 6.5. And it's okay to do that. It's okay to put a half number there. You can do that. Okay. And then what we're going to do to get rid of that is just multiply everything by 2. So if you end up with a half number here, you can just multiply this by 2. Multiply this by 2, multiply this by 2, and multiply this by 2. And now the balanced reaction is 2, 13, 8, 10.